Chapter 3, Fasteners, or more specifically, fastening methods. So, without looking at the slide, when you say fasteners, what do you think of? Just right off the top of your head.
Screws, bolts, nuts, glue, rivets.
What would you say, John?
Rivets.
Rivets, okay. That's what I thought, just wanted to be clear. Many different kinds of fasteners, many that a lot of people don't think about. Staples, glue, tape, nuts and bolts and screws, and what about pop rivets, regular rivets, washers, clothespin, and the list just goes on, right? All kinds of little ways that we figured out how to fashion things together. Think about the old times when the local wood artisan would build somebody a table and use a single fastener. It was all about how the wood was cut, and if there were fasteners, it was just a wooden wedge that they drove into a box they made or whatever, dovetails. It was the list just goes on and on and on and on, right? So, the other one that nobody thinks about is welding. And then that includes soldering and brazing and, the methods that you use to weld. Something as simple as friction or an electric arc, acetylene torch, just all kinds of ways to do it. Okay. So, with that being said, hopefully, I say that a lot, but we usually never hit the mark. But our objectives are to define fastening, compare the characteristics of different types of threaded fasteners, compare the characteristics of different types of non-threaded fasteners, and describe the different types of adhesives used by industrial technicians, explain the welding process used by industrial technicians. So, threaded fastener, screw, bolt, that kind of stuff, right? Non-threaded, rivet, clothespin, whatever. As far as adhesives that are used by industrial technicians, what comes to mind? Epoxy is a very common one. Electrical tape. Yeah.
Some of your like thread lockers, like Loctite.
Yeah, thread locker. Loctite is a brand name, but yeah, I get where you're coming from. You know what the most common one is? It's got old-fashioned super glue. Cyanoacrylate or CA glue. So, threaded fastener is a device that joins parts together with a screw thread. Well, what if you don't know what a screw thread is? I think at this point in our lives, we pretty much all know what a screw is, though. Without realizing it, you've seen probably a bazillion of them through your life. Does anybody want to take a stab at what the various names of those fasteners are?
on the machine screws? Or like roofing screw? So,
Machine screw, bolt. What about this weird looking thing?
it's like a deck screw. It's like a deck screw.
It's for concrete, but I don't know what the actual term
It's
for
a
it is.
concrete screw. Most common one, brand name wise, is Tapcon. And that is specifically a Tapcon. You can tell because that blue is their trademark color. You can make concrete screws, but you can't make them that blue color because it's part of Tapcon's trademark. What about this guy here?
Lag bolt.
Lag, okay? That one? Way longer than we're used to seeing, but it's actually drywall
Yeah.
or sheetrock.
What kind of sheetrock you're putting in with that? It's heavy duty, like,
Heavy duty.
it's a couple of inches.
There's your deck screw. And what about these guys? These over here.
Seen them used like on hinges and stuff like that, but you're talking about like pan head versus being a tapered screw. Is that what you're talking
It's
about?
designed to be pretty.
Huh?
It's designed to be pretty,
Designed to be
right?
So, yeah.
Yeah, I got
You know, like you
yellow
said,
zinc oxide
for,
on it.
for hinges or drawer pulls or, you know,
Yeah, that
Oh,
one,
dear.
that one puppy screw, you see it a lot in like cabinetry. The longer, kind of a panhead style looking screw, but it has kind of like a washer made to it.
yeah,
Down there on the bottom and the head.
this guy right here.
Yeah.
Yeah, so that would be a machine screw there. So lots and lots and lots of different threaded type fastening. Screw thread is a ridge in the form of a spiral on the external or internal or external surface of a cylinder or column. Is a helical inclined plane. You guys ever watch Big Bang Theory? There was a couple of episodes where they trying to get technical. Screw is talking about helical inclined plane around the axis of a shaft, you know, whatever it was that they said, and all the technical stuff. You ever seen a left-handed thread? Righty-tighty, lefty-loosey, unless it's a left-handed thread. So why do we specify thread fastener and a left-hand thread fastener?
For rotating objects. You bolt them together so they don't unthread.
Well, why do you need to have, you know, it's a screw. That's a left-hand thread screw. If you just say it's a screw, you assume it's a right-hand thread. Why?
Why do we assume? Because most of them are right-handed.
Why?
People are right-handed.
Most people are right-handed. Exactly why. We don't have those kind of weird, I don't know, ideas, I guess, for lack of a better word, these days. You know, we're more enlightened now, if you will. There were a lot of people, especially if they went to Catholic school, that if they were left-handed, they were forced to use the right hand. Because for whatever reason, the Catholic Church decided that if you were left-handed, you were possessed by the devil. So, you know, I somehow don't think that's entirely accurate, but it's what they believed. Self-tapping, thread fastener with a tapered point and a screw threads that bite into a compressible or deformable material as it is driven. It'll also be a relatively coarse thread like that. You can actually make pretty much any screw a self-tapper if you're screwing it into the right material. Now you can even take a machine screw, something that is not designed to be self-tapping, and run it into plastic or wood, and it'll form its own threads. Okay. They are available in a variety of materials, sizes, head shapes, drives. I've often wondered how you're supposed to drive a ball head.
So you know, friction.
Like, why?
You pretty much cooking the material until it burns through.
Okay. I'll go with that. We have flat filister, flat countersunk trim, X with washer, undercut oval, countersunk, you know, blah, 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 blah. All the various different types of heads. What they're used for depends on, well, when they're used depends on what they're used for. If you need the head of your screw to be flush with the surface or, you know, slightly below, you would use countersink. But you could also use cap screw, which is the one with the hex drive, Allen key. Those, though, you would do a counter bore rather than a counter sink. Different drive styles, you have hex, Phillips, drilled spanner. Those are the ones you see, safety type deals where, you know, not just anybody carries around a screwdriver that's capable of driving those. The one-way, it's actually designed for use with a flathead screwdriver. You can drive it, but you can't remove it. You think any place that you've seen those around?
Bathroom stalls.
Bathroom stalls. That's, I guess if I really thought about it, I could think of others, but that is the only place that I can remember ever seeing that type of fastener. You know, we'll put the bathroom stall together, and if we got to take it back apart, we're going to break out the Sawzall or hammers or, you know, whatever. You guys notice that we have a Frierson positive drive and Phillips. They all look very similar to each other. You know what the differences are?
It's just the way they're machined internally. Like the bits look different too. Like I want to say the, how you said it, pause drive or whatever, like when you look at it, it has two sets of those, and one's like smaller up towards the top in the part of it.
Yeah, you
Supposed
think of it
create more
cross
light.
drive.
Yeah.
Well, there, you have this cross and you have one that's 45 degrees off of it,
Yeah.
smaller. Yep, that's positive drive. The McPherson, 99% of people out there, if you hand them a McPherson head screw, they'll grab a Phillips screwdriver. Pretty much every time. Same thing with a positive drive. But that's what everybody's used to. What about the fluted socket?
It's kind of like a Torx, isn't it?
Yep. Torx is
Torx
actually
is
a
a
fluted
brand.
socket. Torx is a brand. Yep. Those are arguably the best ones that you can use for not having your driver or driver bit slip out, cam out, what have you. It's a very positive engagement in multiple locations, and it is specifically designed rather than camming out to stay engaged when you're driving it. Bolts and machine screws, differences between them. What are the differences between a bolt and a machine screw? Does anybody know what the difference is between a bolt and a machine screw?
The thread pitch. Well, I guess it's typically finer thread, but
The threads. Bolt usually won't have
Compared to what?
Bolt usually won't be fully threaded, a machine screw will be fully threaded.
Exactly. It is basically the same fastener, but a bolt, by definition, the threads don't go all the way to the head.
it's a shame.
Other than that, that's a screw. Bolt is a large, partially threaded fastener. And also never have an internal drive like Phillips or Torx or Square or whatever. It always is an external drive, hex or whatever. Bolt grade markings. Did you know that there were different grades of bolts? You know what the grade of a bolt means?
It's shear strength.
Tensile strength or shear. Have any of you guys had processes and materials? Yeah. You remember yield strength? That's comes into play there.
There also stretch right there.
And have elastic versus plastic deformation. Elastic deformation, it will return to its original shape whenever you relieve the stress. Plastic deformation, you have exceeded the yield strength and it will never return to its original shape. Basically what that means. Okay. They're also designed for different applications. The lower grade has a lower yield strength. Higher grade has a higher yield strength. The higher grade bolts will typically be larger than the lower ones because they're designed to carry much heavier loads. Doesn't have to, you make a bolt whatever grade you want whenever you're manufacturing it, but generally speaking, the higher the grade, the larger the bolts will be. The marking system, I never really understood myself. Now, if you see no marks at all, it's either grade 1 or grade 2. Could be either one. Why have grade 1 or grade 2 whenever they would have exactly the same yield strength? 3 marks is grade 5. 5 marks is grade 7. 6 marks is grade 8. Why not put 3 on the 3, 5 on the 5, and 8 on the 8? It doesn't make sense to me. Bolt machine screw sizes include nominal thread diameter and the number of threads per inch, or TPI, separated by a hyphen. So there are 3 things that you need to know whenever you're defining a screw type fastener. You need to know what the diameter of it is, the nominal diameter, 1/4 inch, threads per inch, 20 bolt or screw, and then the length. Those are the 3 criteria that you can use to define every fastener. And then you have to worry about what the drive mechanism is. You guys know what the difference is between major and minor diameter?
If I remember correctly, major is the outside. Basically, it's the very edge of like the threads, and the minor is the inside. Piece of that is.
Exactly. You have a it kind of looks like a bolt, doesn't it? I mean, sort of. Major diameter is just the diameter of the bolt, so it's 1/4 inch bolt is 1/4 inch major diameter. Okay. The minor diameter is at the bottom of the threads. Okay. That's all that means. Washer is a small metallic disc with a hole in the center. You're doing it ahead of a bolt or a screw and or under a nut. Spread the load over a larger area. Or can be used to lock the fastener in place. Can be used to take up the gap. Or just make it pretty. So how would a washer make it pretty? Anybody got a thought on that?
So the marring surface.
Use for marring the surface. Exactly. You didn't read the book, did you? Okay, you have your flat washers and a lock washer. Flat washer is just that, it's flat. You also have conical shaped washers in some instances. Some of them have a gasket on one side designed for sealing a hole against dust or water or whatever it is. You have your various types of lock washers. One most people are familiar with is just a split lock, and it's twisted just a little bit. So the profile of it looks more like that. And then you have internal teeth, external teeth, or both. Countersink, the teeth on it are kind of band up, I guess, or down, depending upon which way you turn it. So here's a good question for you. How many times can you use a lock washer? One time. How many times most people use lock washer? Over and over and over.
Until it's flat.
Yeah, a lot of people don't understand that. The lock washer is designed to be engaged, and then if you have to remove, you take it and throw it away and go get a new one, because it has served its purpose. It will no longer lock properly after it is used and then removed.
You seen any of those? Seen it on more like European type equipment, but like it looks like a flat washer, and it usually comes in a pair. But they've got little teeth bridges in them.
Yeah.
So they'll slip lock, and then they do their thing. They're pretty wild looking. Europeans have a lot of weird looking lock washers.
Well, I will keep my comment to myself. What do you say, John?
The ones he's talking about is kind of funny because they actually were invented here in America.
Really?
They were used on airplanes until they put the safety wire.
Interesting.
You know, I've seen a lot of wild looking designs.
Yeah.
Come off of European, like European cars and stuff. You'll see a lot of them that are got wild designs to them. I got a Volkswagen I'm working on right now. It's got a washer that's smooth on one side, but it's textured on the other. You know, it was on the CV axles on the Volkswagen. It's kind of weird.
That makes you put that back on in the right direction.
I think it's meant to bite to the, I remember right, it was facing, if it was put on there right from years ago, it was the texture part was facing the face of the CV shaft, and the bolt was to the smooth part.
Yeah, that would be my guess. Okay, a nut is a small block of metal with an internally threaded hole that is threaded onto the end of a matching bolt or machine screw to assemble a stack of parts. All kinds of different kinds. Have a track bolt, regular square, machine screw, X jam, X thick. What's the X jam?
It's two of them be used together. So you turn them to lock it opposed to one another. Jam nut.
Okay.
It's just like
How does it work?
you run one bolt down, or like if you're using a rod end, you would put it on. You have the jam nut on there. You put the rod in where you want it, and then you run the jam nut to it, pull it tight against it. So it pushes against the threads to lock them in place. And it's like it's trying to
In
stretch
opposite
it.
directions.
Yeah, it's like trying to stretch the bolt in between.
Yeah. You're actually locking the nut in place because it is fighting the threads that it's threaded onto and the nut that it's up against. So, lots and lots of friction. What about the slotted or the castle or designed for?
So you can pin it.
The cotter pin it. Acorn.
Look pretty.
Makes it look pretty. Yeah, who wants to see all the ugly old thread sticking out of the end of that nut?
I've seen very many 12
And
volts
also,
now.
I see them on a lot of kids, because I had to put my kids' bikes together. I see them on a lot of those.
Safety as
Like
well.
a safety issue. I would consider it a safety issue, because that's what I see.
it also prevents the end of the screw or bolt from getting deformed and getting jammed.
Yeah,
Yeah.
most of the ones that are designed for safety typically end up being plastic, and it's just a cover. Not always, but frequently. One thing we didn't think about earlier was good old fashioned nail. Nail's been used for thousands of years. Romans used them very effectively. Nail people to trees like Jesus. I've also seen a lot of depictions of crucifixion where Jesus was the only one nailed and the other two that were crucified with him were just tied to the cross. They nailed everybody. The Romans were very good at inflicting the most amount of pain possible without actually killing you. And I don't know if you ever, hope you haven't, had a nail driven through one of your bones. That, I would imagine, is probably one of the most painful things that you can endure.
Yeah, it's really bad.
Nail derives holding strength by friction with the wood along its length. They're especially designed. The grooves at the tip, a lot of people think that those are there just to hold the wire whenever they manufacture it, smack the tip of it to put the head on it. While that's where they come from, it's actually a design thing to help hold the nail in the wood. You ever mad at yourself because you drove a nail at an angle? You know, that actually makes the joint stronger if you drive it at an angle. A lot of people don't realize that either. Nail sizes. Nails are designed by the penny unit. John, didn't we have this conversation last semester? Was that you and I that were discussing that, or was somebody else? I had a lot of classes last semester.
I've had this discussion with someone else too, and it's especially why it's the D as a symbol. It's the penny.
Do you remember why it's a penny?
That was the forger would charge by the size or something.
It had something to do with weight.
I can maybe see that. Weighs the same as a penny. You know, for the size. 16 penny weighs as much as 16 pennies. Don't weigh very much.
It is, I can't remember exactly what it is. It's not the same as it used to be. It's more like a relic. Because back when they were actually like cut nails, it actually was more relevant if I remember correctly. It's been so long since I've actually looked into it.
The size of the penny is the size of the nail. You know, like the diameters. The cross measurement.
Was how many tens or how many hundreds or whatever it was that you could buy for a penny? I think, if I remember right. Somebody Google it.
I want to say it was based on the number of, like so many of, like this much weight of nails was worth this much. And it's based off that.
You could fit more, like 2 penny would be 200 or whatever it was. I don't remember. Been a while since I looked it up, but John's going to Google it for us.
The historical price was 100 nails in pennies. So 100 nails cost them 10 pennies, were 10 penny nails. And it basically, in the typical way it works is it denotes the length.
Okay, so it's close.
The question is, why is it the D?
I'll Google that too.
It comes from the Roman denarius. Didn't say that word right.
All right.
It's basically it's the same reason why like pound, shilling, pence is labeled LSD. The D is the Roman word for basically the standard coin. It's denarius or something like that.
Denarii would be the plural. Okay. So original rivet designs were installed by inserting the rivet through the hole, pressing or beating the inserted end to form a head. You had to have somebody standing on the other side with what was known as a buck bar, so that when you smack the rivet, it didn't just pop back out the other side of the hole. Okay.
That was a horrible job. I've seen
Have you
videos.
done it?
No, I haven't ever had to do it, but I've seen videos of guys doing it. It doesn't look fun.
No.
It doesn't look fun at all.
Can you imagine being, 10 stories up in the air, somebody throwing hot rivets at you? They would put them in the furnace, get them red hot, and then they'd sling them, and you have a slinger and a catcher and a beater.
Watch guys.
I guess a backer too, because you had to have, the slinger would heat them up, sling them to the catcher would catch them, stick it in the hole, and then the guy with the buck bar would stand behind it, while the other dude with the beater would smack it on the other side.
I watched them rebuild an old train, steam engine train. I felt sorry for the guy on the inside of the boiler tank with the buck bar. The guy on the outside,
And you can imagine what his hearing was like. What's that you say?
The hot rivet come through that hole, and then he's like, you see bits of metal kind of flaking off of it.
Mm-hmm.
It's pretty wild to watch.
Which nowadays they actually make some special rivet guns that you basically use an induction heater to heat up the rivet, and then it can just do it from one side. It doesn't heat the two people. That's tricky. Because it basically uses the vibrations to cause it to mushroom on the other end, and it's
Weird stuff.
physics can be fucking.
Different head styles. All about it. It's supposed to be pretty or not. or the flat countersunk. Those are the ones that they use to assemble airplanes with. But the fuselage needs to be as smooth as possible. Any turbulence whatsoever causes drag. Drag causes the slow down. Prop rivets. I think that's, yeah, there's pop rivets. You know what are called pop rivets?
Offset shank off, whatever.
Dynamex. It's designed to fail at a known point. And when it does fail, it'll pop. The actual name is a blind rivet because you can do it from one side. Keyway. Key is just a small piece of metal that is designed to be inserted into a gear and shaft primarily to prevent the gear from spinning on the shaft. You have the square ones like that. You have a Woodruff, which is the half moon style. Depending upon what material it's made out of, it can be designed to fail, like on old Briggs and Stratton engines, the shear key on flywheel. If you hit a tree stump or whatever, it would shear the key, which is pretty ingenious. You know, it would withstand a certain amount of force, and after that, it just fails. But do you know why it stops the engine?
Because the ignition is attached to the flywheel, or operates off the flywheel, the ignition system does.
Okay, so how does it stop the engine?
By stopping the spark.
Sure.
Well, 'cause the coil sets on the outside of the flywheel, and it has a magnetic field that passes it. It fires the spark plug. If it stops moving, it will not spark no more.
You can still spin flywheel.
It usually will stop. The rotating mass disappears. It'll let the crank stop as well. Hit something.
Now you look like you want to say something.
I'm trying to remember. I want to say it actually stops the fuel injection. Or is it the one that stops the valve in the carburetor?
It definitely has to do with ignition. You ever heard the term ignition timing? You shear the pin, and the magnet that's on the flywheel is no longer lined up with where the piston is supposed to be when it fires.
What's the flywheel?
So what is it?
Oh, flywheel is typically just cast aluminum. And it has some kind of ferrous metal embedded in it, and then a counterweight on the other side, so it's balanced. Yeah, it just changes the ignition timing, and if you don't have the spark when you need the spark, you can still have a spark, but it was at the wrong time, nothing happens. Three main types of key: parallel, taper, and Woodruff. Woodruff is the one that is the half moon shape. The taper is designed to get tighter as you drive it in. You drive it the other way, it just pops right out. So it's much easier to remove than a standard square key or a Woodruff key. Woodruff key is also designed to be, instead of the slot going all the way to the end of the shaft, it's cut into the side so that the key can't move on the shaft. Pardon me, when we get out there in the lab later in the semester and we start dealing with keys and set screws and whatnot, make absolutely certain that there is a key under the set screw before you tighten it down, because if you tighten it down on the shaft, you will damage the shaft and then you won't be able to get the gear back off of said shaft. Okay. Pin is a cylindrical fastener that is placed in a hole to secure the relative positions of two or more parts. It can also be used to prevent two parts from rotationally disengaging with each other. Castle nut and cotter pin. Yeah, there we go. Wide variety of pin sizes, types, materials, straight, taper, cotter, clevis. The slotted springs, those are the ones that drive me nuts. It's tapered on the end just enough to get it started, but you have to drive it with a hammer, and the first time you smack it, it goes. So you have to pick it back up, and then you get it all frustrated, and you have to hold it on there with a pair of pliers, and you know, it's just a gigantic pain in the butt. So, the coiled spring, I've never actually seen one of those that I can remember. You guys seen one of those?
I've seen it once. And it was actually, like the actual thing was, it was for it was on an old fire.
Okay. An adhesive is a substance that is used to bond materials together at the surface. If the adhesive is used properly, the joint should be stronger than the material that it is adhering. People, you know where Post-its came from? And he was trying to make an adhesive stronger than CA and failed miserably. It was actually at 3M. And then somebody came up with the idea, well, hey, you know, this is just sticky enough to stick without marring up the surface. So, you know, we're constantly trying to write notes or, you know, whatever on documents and that sort of thing. And so it was a chemical flub. And then somebody thinking outside the box turned into a Post-it note. And, you know, now you got Post-it notes that are square and they're different shapes and they're fan fold and different colors. And, you know, the sign here, arrows, you know, the list just goes on and on about those. And it's amazing how we can invent something by accident.
Super glue is the same way. originally trying to make lenses for, can't remember if it was telescopes or what, during one of the wars. And they kept having issues, like they'd accidentally stuck something to one of their pieces of test equipment.
Couldn't get it off.
It was like thousands of dollars at that time. And it was like, it was an annoyance then, and then almost like a decade or two later, they went back and revisited it as an adhesive. That's everywhere.
Yeah, you can even buy it from China. 10 tubes of it for a nickel or whatever it is.
It's amazing how it reacts to other stuff. You know, like
Yeah.
using it with like wood, or you use it with baking powder or baking soda.
Baking soda.
Baking soda. I use it with baking soda all the time. Stuff, and it gets really hot whenever it starts to work. But yeah, it makes kind of a hard plasticky
Yeah, it's machinable.
material. Yeah.
It's actually machinable.
Yeah, I use it to repair whenever I have to fix like broken legs, like on a chip. When the legs will break, I'll take my little die grinder and grind back to get to the legs. I put new legs on a chip you can't get because it's no longer made. And then over the top of that, I'll use that to reseal it and bond it together. And yeah, you can file that. You can do whatever you want with it.
Yep.
It is a good repair.
We're looking at using CA for all kinds of stuff because it's one of the few polymers that you can actually depolymerize. So they're looking
It's used in surgical suites instead of stitches or staples because it bonds your human skin instantly.
It hurts, but it works great to hold it cut together.
I can't tell you how many times I've used an electrician's Band-Aid. Like tape. Works great. But if you don't happen to have any, and you got tube super glue laying around, but it burns. You wouldn't believe how much it burns.
At least you know it's disinfected.
not quite.
I don't know.
So anyway, that's various types of adhesives and cure times and whatnot. Epoxies are multiple parts. You mix each part by itself, doesn't do much. If anything, you mix them together in the correct ratios and it becomes an adhesive or long chain polymer that you machine or whatever.
What is the actual thread locker? Like, it will dry, but they reading on the thing, like it's not really supposed to cure till it's under tension, under pressure.
Well, all thread lockers are anaerobic.
Anaerobic.
Which means that it is the absence of oxygen that causes them to cure. So whenever you put your fasteners together, your nut and bolt, whenever you screw it in, tighten it up, you're displacing all the oxygen.
So then it cures.
It's anaerobic, so that's when it cures.
I know they use green on brake pads.
Yeah, the color, what everybody goes by. Blue Loctite or red Loctite.
It's all those different formulas, but they color it for different purposes.
Yeah, so it's identifiable by sight. Adhesive tape is a strip of material coated on one side or sometimes both with an adhesive used for purposes of fastening. Double-sided sticky tape. Well, if it wasn't sticky, it wouldn't be tape, would it? Oxyacetylene welding, or OAW, is an oxy-fuel welding process that uses oxygen mixed with acetylene. It can either be used for welding or cutting. We're rapidly running out of time here. Shielded metal arc or SMAW is arc welding, where the electrode itself is consumed and there is a flux that is on it that as the welding process happens, it's electric arc. The arc gets to like between 6 and 10,000 degrees Fahrenheit, actually melts metal. In SMAW, the flux that is around the core burns, turns into a shield gas and then a slag to protect the weld from oxidation. And then the other one is S in here is GMAW, or gas metal work, which is the fancy way of saying MIG. It uses a shield gas, which is typically argon. What are the general definitions of non-permanent, semi-permanent, and permanent? Well, what's non-permanent?
Screws, bolts.
Easily removed. Semi-permanent? Removable. And permanent. Good luck getting you back off. Describe the primary difference between self-tapping screws, bolts, and machine screws. What's self-tapper? Forms its own threads. Screw, bolt, machine screw.
Whether threads go all the way to the head or not.
Eventually, yeah. And the type of drive on the head. What's generally accepted differences between bolts and machine screws? We just talked about that. How are bolt and machine screw sizes designated? What are the three criteria?
Thread diameter.
Diameter. Be fastener length, not just threads. Huh? Close.
Thread pitch.
Thread pitch. How many threads per inch? Unless you're talking about metric, and then it's how many threads per millimeter. But this is America. What is the purpose of a washer?
To distribute
Load. Okay. Make it look pretty.
I walk it.
You're on the right track.
Load. Make it pretty, and then also to help make it easier to get the bolt back out.
Hold the gap. Hold the gap. One more.
Slide bolt.
Lock washer. There you go. What is general procedure for applying adhesive tape? Done. Now, the answer that they're looking for, that you will find in the book, is basically you have to apply it and then put pressure on it to get it to actually engage the adhesive. How is electricity used in arc welding process?
To conduct the metal.
That was a lot closer. The electric arc generates the resistance of the air gap between the electrode and the material that you're welding. It causes it heat up between 6 and 10,000 degrees, which actually physically melts the metal that you're welding. What's the main difference between shielded metal arc and gas metal arc? There you go. That's pretty straightforward, isn't it? Shielded metal arc, you have the flux is part of the electrode, and gas metal arc, the shield is a separate gas. And last but not least, what's the difference between brazing and soldering, which is not something we talk about, but it is in the book.
Typical material used for application.
Brazing is more for copper.
Not necessarily.
Solder copper, but
The exact process.
What about it? We're on the right track.
they both use a flux and they both use heat to apply them.
Okay, you're on the right track too.
The brazing has a tendency to almost kind of melts into the material a little more. Solder doesn't, it just lays and kind of bonds the two.
Kind of fills in the gaps.
Yeah, it kind of fills in the gaps.
Solder's gap filling, whereas brazing is like.
So why does one fill the gap and the other one actually bond?
As long as penetration, but that's.
Yeah, well, you're right, but why is one penetrate and the other one not?
Different components.
Are you kind of melting it?
What'd you say? The amount of heat. That is the primary difference between brazing and soldering, is how hot do you get it? It's essentially the same process. But whenever you're brazing something, you're getting it a lot hotter than you have to just solder.
Both of them, if you get them too hot, they won't work either.
They also both have to be clean. That's why you use the flux.
I made that mistake with brazing, got it a little too hot, and then it wouldn't take.
Or you end up turning what trying to braze into.
I think as you get it
Pile
hot
of
enough,
metal.
the carbon starts trying to come out of the materials or whatever, and it creates like an oxide layer on you, and
It's no longer clean.
yeah, it scales up, and it won't no longer adhere to it.
It's no longer clean.